Now we go to fundamental problem 17. Okay, now here we have two plates. Okay, one is plate A and another one is plate B. Plate A is heavier, which is it is 100 Newton, while plate B is the weight is 30 Newton, right? And then it is supported with this kind of configuration. So you have two pulleys, right, with ropes. So you have the rope goes this way to the pulley and goes stop here, right? I mean supporting this way, and then again on the left hand side, it is the same. And you can see that actually symmetrical bodies exist, right? But okay, it's fine. It's not that important. The symmetry, and you know that the distance between these two is 1.2 meter, while this distance is 0.3 and 0.3 meter, right? So the question asks you to find what is the normal force exerted by this plate A, which weigh 100 Newton, to this plate B, right? So how do we understand this problem? How do we understand this problem? We need to understand that what happened here is actually this one, I mean both are supported by the pulleys, right? But this one, plate B will have to support the weight of it as well, right? And you need to find what is the normal force that actually this A, okay, exerts on B, right? So let's start with the free body diagram of plate A. Okay, what do you have at A? You have its own weight, right? First one, which is how much? It is 100 Newton, isn't it? It is 100 Newton load at the center, which is at the center. Okay, because it's a uniform plate. It's not mentioned, but you can say that it's a uniform plate, right? And then at these two points, we have the supports of the rope, which is connected to the smooth pulley, isn't it? So we have T1 and T2. Okay. At this point, you still don't know whether they are the same or not. Actually, you know that they are similar because it's symmetrical. But if you don't know, then you say that okay, this is T1 and T2. You will prove later on that they have the same thing. They are symmetrical. And then what else? This is not enough. There is something else. You see that there is a contact between A and B. Okay. So you have this normal, alright? Let's name it as NW, whatever name that you want to use, right? Or NAB. The normal force between A and B. Okay. Why there is NAB? Because there is a contact between A and B. Alright? So if you do not include NAB, then everything is wrong. Simple as that. Right? Okay, we assume that of course it's a distributed load, but we have the equivalent of NAB at the center, right? In this case, your T1 and T2, they are the same. How do I know that? If you remember about this center, right? These two will be eliminated in the equation for that moment, while you have T1 times this times minus T2 times that equals to 0, and then you will see that T1 equals to T2. Now you can see that they have the same tension. T1, T2, they have the same tension. If you name as T, this one will be T as well. Okay, later on. Alright, that's one thing. And then if you do Fy equals to 0, now you will end up with 2T, isn't it? T1 plus T2, 2T minus 100 minus NAB. Okay, the reaction, the normal force that you want to find equals to 0. So your here what do you want to find? Later on, of course, you can solve this directly here. You will the second body, which is plate B, to solve that. But what does how about this one? Which one do you want to express? NAB in terms of T or T in terms of NAB? Now you need to understand. I mean, it doesn't matter actually, really. But it's just the one which is straightforward is actually you express T in terms of NAB. Why? Because actually the question asks you to find what is NAB. The question doesn't ask you to find what is T. right? So you express T in terms of NAB, you bring everything over there, I mean, and then divide by 2, so you get your T equals to 1/200 plus NAB. Sorry, this is plus, right? Okay, plus, sorry, plus NAB, so this is minus 100 minus NAB. Right? So this is the relation between T and NAB. You'll solve this NAB later on. I mean, you need the second body. So you do the flow diagram for plate B, right? The longer one. What do you have? Of course, in the middle you have its own weight, which is how much? 30 Newton, right? And then at this and this you have T. Now I know both are T, right? Initially, I mean, if you don't find this, you will say that okay, this is T1, this is T2. Okay, T1, 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 T2, 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 right? T1 and T2. But because you have solved this by using moment about at the center here, you know that T1 and T2 are the same, so you just name it as T, so you know that this is T, this is T, right? What else you have? You have another one, which is this NAB itself, right? The normal force, the contact force, NAB, right? At this second body, and then please check this. For NAB, for free body diagram point A, you have it going up because it is supporting, right? While for point B, not for point B, for plate B, NAB going down because it is acting on the surface of this, right? So the direction must be correct. I mean, if you assume NAB going down, then you get negative here. But you need to do I mean, if you do this one going down, then this one going up, right? But this is actually the correct assumption, right? So for this one, what you have to do is you will do. You can relate them, right? Fy equals to 0. So you'll have 2t plus the t, right? 2t minus the t, right? Minus NAB equals to 0. You assume going up as positive, right? You have t from before, so you do this 1/2, right? 100 minus NAB minus the T minus NAB. Can you see that now you have only NAB in the equation? That's why you express here T in terms of NAB, not the other way around, right? So that now you can find your NAB. You solve this. This is just simple algebra. Okay, solve this NAB, and then you will get your NAB to be 35 Newton. Alright. Here you don't have to find T. That's why